Hello Internet, I'm Remote Leg, and welcome to the LifeStyles project, a study of A-Life. We progress! Now I have a world in 2 dimensions where each location has quantities of substances rather than individual atoms. Here I have a main control panel. This is our old friend the map, showing a top-down view of the world. This panel selects what the map will show, and last I have a scrolling text box that lets the program send me status updates. Yes, the map is a little small, but each pixel displays a location and the world is 300 locations square. The map is dynamically created, so when I make the world bigger, the map should automatically increase in size. I decided on a physical model that allows just 10 substances to exist. This is my periodic table, if you like. As you can see, there are 4 types of substances: energy, gas, liquid, and solid. The type of substance is defined by the mass of the atoms. You'll notice I'm still referring to atoms even though they no longer exist in this world. Well, I recycled quite a lot of code from the original model, and the word atom is everywhere. It's too much to clean up, so you're just going to have to bear with me. Wherever you see the word atom, you could think of it as saying substance. The information on this table is imported from a data file, so it's easy to change. That might come in handy later if I want to add more gases, lighten the mass of something, or change its color. Nothing is hard-coded. In this world, it's easy to edit the data file and turn lead into gold, if we had any lead, or gold. Starting at the top, we have 2 energy substances, defined by them having a mass less than or equal to 0.01, let's call the measurement unit grams. Next, we have gases that weigh above 0.01 grams up to 2 grams. Liquids can weigh as much as 4 grams, and all the rest are solids. I know that the 2 energies of light and heat are not substances per se, but bear with me. I'm thinking it might be useful to treat heat like a substance, so we could get it to flow from one location to another like a liquid. I have complete freedom to mess with the physics, so why not treat it as a substance? It just looks useful. Once I write the code to flow a liquid from one location to another, I can recycle it to work for gases and energy. The chemists among you will also cry that water is not an atom. Who cares? These are just labels, so I can visualize what's going on. So are the colors, for that matter. It's just easier to visualize what's happening to a liquid named water that's blue rather than one named bromine that's orange. Transmutation is a good physical law that I thought up. You know how ice will change into water if you apply heat to it? Well, I decided to apply that law to all the substances, except the energy ones. In detail, if you apply the transmutation number of units of heat to a substance, 1 unit will transmute into the next higher substance and absorb those units of heat. If the substance cools sufficiently, it will transmute back into the next lower substance and release those units of heat. So, if you heat salt in this world, it will transmute into water and absorb 7 units of heat. Cool the water and it will transmute back into salt and release 3 units of heat. This works all the way from soil right up to ether. What we have here is a type of energy gradient that creatures can use to survive. Creatures need energy to live. So a creature might evolve that can eat foam, extract the 2 units of energy, and excrete water. The only boundaries I put on it are that energy does not transmute, and neither does bedrock. I'm going to use bedrock to sculpt the surface of the world, and I don't want it to evaporate. I'm still not certain about making energy into a substance, though. Dissipation is just the rate that a substance will flow to an adjoining location. Light flows very fast, and bedrock does not flow at all. Here's the data structure for substances. I won't linger on this because I don't think anybody wants to wade through lots of code. We have some world boundaries at the top. These are followed by the structure that every substance uses and the array that stores the substances and their information. Lastly, we have a few indexes to identify where each substance type starts: energy, gas, liquid and solid. Notice the map is showing liquids, so each pixel shows what's at that location, either foam in light cyan or water, cyan. If both are present, it picks the highest substance on the table, which is foam. So let's fire it up and see how it goes. Little black dots appear everywhere. Why? A black dot means that there is no liquid at that location, so it's pretty apparent that the foam is transmuting into water and the water is then freezing down into salt. That's because there's no heat in the world. But hang on, doesn't freezing release heat? Where did all my heat go? One rule I forgot to mention is that energy dissipates, otherwise the world would overheat. I thought I would see some here though. Let's reset the world and watch the heat. I love this reset button, reset the world. It makes me feel very powerful. Aha, here's some heat and light. Okay, let's run the world again and see what happens. That looks about right. The light and heat dissipated, but the cooling transmuted all the substances, releasing heat until everything froze into soil. If we look at the solids, we find that everything became salt. I was expecting to see a lot of sand and then soil. Alright, that's my homework for this week. I need to find out why the world did not turn entirely into soil. When the transmutation is working properly, I need to build a sun so I can add energy back into the system and boil those solids back into liquids and gases. Boil freeze, I'll give those creatures something to think about.